Okay, so here's a video on lesson 67, exponential equations. Now, this whole lesson is based around this idea. Okay? The idea is that if I have two bases, okay, so let's just say they're 3. All right, 3 is equal to 3, and they have different exponents. For instance, if I said that this one has an x, but this one is a 4. If 3 to the x equals 3 to the 4th, isn't it obvious that x must equal 4 then? If I substituted a 4 in here, then these would be equal. So x must be equal to 4. So if I give you something more complicated than that, for instance, if I said that the base 2, right, of 4x plus 1 is equal to 2 to the 17th. Doesn't the same logical reasoning as before dictate that these must be equal? That 4x plus 1 must be equal to 17 then. So it's almost like we're crossing out the bases and we don't care about them anymore because the bases are the same and they're set equal to each other. And this gives us a very easy to solve equation. We can minus 1 on both sides. We get 4x is equal to 16, and I can divide both sides by 4 to find that x is equal to 4. So these can give us linear equations, or they can even give us quadratic equations. And I want to explore with you a little bit of both options. So let's pull a question from the front of the page. The problem is that the bases are not always going to be equal. But here's the equivalence that allows this to work. Question 7 says 2 to the x plus 1 equals 8. Now, these have a common base in that actually 2 times 2 times 2 equals 8. So I can take the number 8 here and change it into 2 cubed. And now, when I rewrite the left-hand side, it becomes obvious that I have the same base and a different exponent, and I can set them equal to each other. X plus 1 equals 3, minus 1 on each side, and you get that x is equal to 2. Okay. Let's do one where we have to change both bases. For instance, question 16. Question 16 says 8 to the 2x is equal to 4 to the 6th. Now, I can't change these into the same base. For instance, 8 is not 4 squared. I can't do this because that's not equal. Eraser's way too big. Okay. Those are not equal, so that's not going to work. So what I'm looking at is what do they have in common? Well, 4 could be rewritten as 2 squared. 2 squared is 4. 8 can be rewritten as 2 cubed. Now what I need to do is I need to bring along the exponents I left behind, which means that this is raised to the 2x, and this is raised to the 6th. And these are still equal. Each one of these terms has a power raised to a power. If you've been reviewing these lessons, or if you remember from lesson 65, when you have a power raised to a power, we're multiplying them. So 3 times 2x is 6x. So 2 raised to the 6x power. Same thing on the right-hand side. 2 and 6 are both exponents, so 2 raised to the 2 raised to the 6. I'm going to be multiplying them. 2 times 6 is 12, so 2 to the 12th. And then the rest of it becomes very obvious. Well, then 6x must equal 12. And if you divide both sides by 6, you'll get that x equals 2. All right. Now let's do an example that involves a quadratic solution, because this is the furthest that I'm going to go with it. Let's pick, I think they're on the front. That they are. Okay, so let's use this question number 6. Question number 6 says that 4 raised to the x squared plus 4x power is equal to 2 raised to the negative 6 power. I'm going to pull this over to my loose leaf so I have a little bit of room to work and I'm not cramped. Now, these don't have the same base yet, but I remember from the previous question that I can just turn 4 into 2 squared. So here's what I'm going to do. 4 becomes 2 squared. Now I need to bring down the exponents that I left behind, which is x squared plus 4x. On the right-hand side, the 2 is already fine, so 2 to the negative 6th. Now they have the same base, but I still need to deal with these exponents on the left. So what I'm going to do is I'm going to distribute the 2 into the exponent, because that's how we multiply. So I get 2 raised to the 2x squared plus 8x. Take a second to digest that, jump back 15 seconds and watch it again if you need. On the right, I get 2 to the negative 6, still hasn't needed to change. And since the bases are the same and they are set equal, we can conclude that this must equal this. So 2x squared plus 8x is equal to negative 6. Now I have a new problem. It's almost like an old throwback problem from September. I have a quadratic. Now all of them are even, so I can make my life easy. I can divide everything by 2. Divide by 2, divide by 2, divide by 2. Now I get x squared plus 4x equals negative 3. Now anytime I have a quadratic, I've got 2 x terms. There's no way that I can get rid of those. I'm going to have 2 different solutions. So what I need to do is I need to set the equation equal to 0. So if I take this, I'll put it on the right hand side so I don't have to get rid of my old work. X squared plus 4x equals negative 3. I don't like it when my quadratics are equal to negative 3. I like it when they're equal to 0. So I'm going to add 3 to both sides. After I do that, I get x squared plus 4x plus 3 equals 0. And now I know it's a throwback, but you definitely know what to do here. 2 things that'll add to 4 and multiply to 3. So let's think of what multiplies to give me 3. 3 times 1, and negative 3 times negative 1. Well, 3 and 1 would add to 4. So those are going to be my 2 numbers. So this gets double bubbled. X plus 3, x plus 1, all equal to 0. And I t-chart for my final answers, negative 3 and negative 1. So this had 2 solutions. If you want to try a question just like that, find another one on the front of the page that has a x squared up in the exponent somewhere, and it'll play out exactly like this. Okay? If you have any questions, you can feel free to see me in office hours. Remember that all of these handouts are available on my website. You can go to mrjcostello.com. You can go to Algebra 2, and you can click on Files, and you will see all of these there. Okay? So Mr. J. Costello, Algebra 2, and then Files. Good luck. See you in class.